We've had this conversation and you seem to agree with me, but when there's complications, you withdraw and leave me to be. When there's a problem, you become like a wall, and every time I trip, it's a free fall. Why don't you help me the way I help you? You don't have to save me, just be my parachute. When I'm feeling down, you're just not there, making sure I'm okay. Why don't you help me the way I help you?
Hi everyone, welcome to New Tech. My name's Miles and thanks very much for watching. In today's video, we're going to be checking out my Mpcnc Primo, so stay tuned. So about 5 years ago, I started with my very first CNC build, and that was the original Mpcnc Burley version. And from that point, I learned so much about CNC, and especially on how they're built and constructed. I actually found it a lot harder to put this machine together than I did with my Workbee. So if you're looking for a really great kit machine to put together, and if you have a 3D printer and you want to invest some time in creating these machines, I certainly think that it's a great idea to invest your time into one of these machines. So throughout today's video, I'm going to talk a little bit about what I've improved about my version of the Mpcnc Primo version, and then I'm going to talk about the electronics that I've used. But before I start with that stuff, I want to tell you a little bit about why did I decide to rebuild or build a new Mpcnc, considering I've already got my my large Workbee CNC, and that's still going really strong. I love that machine. I have my rotary CNC, which I also love using for anything that's round or cylindrical. But why did I decide to go back and create a Mpcnc, which stands for, if you don't know, a mostly printed CNC, and that's a project by V1 Engineering. So I decided that I wanted to rebuild this for two reasons. The first reason is it's kind of revisiting a bit of nostalgia from my past and seeing how I could build something and seeing how much I've learned within that time. So I've built it, and I've improved a massive amount of construction elements and also the electronics about this machine. So I'm going to go into detail about that soon. But the second thing that I wanted to build it for is more for educational purposes and teaching people about what CNC is. So this machine had to be somewhat portable and could fit in the back of my car and could be driven to locations with me. And I think that I've done a really great job in fulfilling that criteria that I initially set out to do. So it fits in the back of the car really well, and I'm really excited to take it to locations to teach people about CNC. So let's jump into firstly the modifications that I've made to the Mpcnc. So the first thing is, you can see that I've upgraded my my brackets that hold into the table. Now, the reason why I wanted to do these brackets was that my machine, I've got these poles exposed as about 110 millimeters. So these brackets for any machine that has the visible pole for about 100 mil and above. So the reasons why I wanted to build them is that they had a 45-degree angle and also reduced any swaying or flex to the machine. So it's super rigid now using these brackets. It's certainly not necessary to have it, but I wanted to push this machine to its limits, and that means I wanted to have something that was really secure and strong. Now on these end brackets too, is that I also have these little corners that come up to hold my aluminium brackets for the wiring. Now that's really handy because it's floating up and I can access, put material underneath, so that works out really well. Now, the second thing that I've upgraded is putting fans on my Nema 17. So these fan housings just slip on and off. The idea is that the air enters in through the top, pushes down the sides of the Nema 17, and then pushes out the small gaps at the bottom. And that's working really well. So I'm pushing these motors at absolute maximum. They haven't skipped, they haven't overheated. since I've been using those fans. So I'd really suggest, if you're like me and want to push the machine to its absolute maximum, having some fan motors on your machine is going to be really helpful for the long term of the health of the machine. Now, I've also upgraded the vacuum system for this machine as well. So if you've watched my previous video, I created I call it a Koala Vac. The idea is this vacuum housing. It just kind of grabs hold of the back there and is hidden. And that stops it from creating too much bulk out the front there, because as we all know, once you start to add the vacuum system in front of your spindle, you start to lose a lot of your machine space. So having it at the back here hides it really well, and also reduces the amount of space that it's used. So I haven't had a good chance to run that yet, but I've put the files out there for you if you want to have a look at it and give it a go for yourself. They're certainly there and available for you to download. So it does give you a bit of a hint what I have and haven't been doing with this machine so far. So I haven't been creating any dust to the machine. I haven't put a spindle on there yet. Now, I don't really have a use for that because I have my Workbee CNC to run all my timber stuff on. So this machine for me was really about creating a machine for creativity. So things that are everything but cutting timber. Now, those things are, such as using your pen or painting or even laser engraving and things like that. But I'm going to jump into that stuff later on in the video. So one other thing to take note of here with the electronics is that I've added my end stop to the base of my Z-axis. So I've just put a wire down the center there and popped it out the bottom and just used a zip tie to hold on that limit switch at the bottom. And that works out really, really well, and means when I home my machine at the very beginning, it goes to its maximum height. And then you can bring it down and set it to your Z-axis, your Z height as needed. So that's a really nice addition to have. Now, I'm going to talk a little bit about the electronics and what's underneath this build. So as you can see that I've created this custom table, and that uses a 30 degree, like a chamfer around the side there, and it's kind of, the idea is to hide it a bit so it's kind of floating on top. But the other idea is that I wanted to put a drawer underneath so it's easily accessible to put items into, and my electronics on the other side. So as you can see on the very front of my machine, I have 4 switches. The very first switch is to disable my motors. Now, sometimes when you're moving your machine around, you just want to make slightly different adjustment and you might not want to move it, or you might be halfway through a job and you've paused it and you can't move the machine. So to be able to disable the motors and move the axis physically sometimes can be quite helpful. The next button I've got, or the next 2 buttons, I've got a little rocker switch there. Now there to control the power outlets at the back of the machine. It's really nice to have access from both directions. I can turn those power switches on and off at the back and at the front. Now I've added them so I can put in extra things like lasers or vacuum cleaners or even a spindle, and I can just attach it straight to the back there and physically just turn it on and off from the very front of the machine. So it's really helpful to have that access in the little control panel. The very last switch I absolutely love. Now this is a feed hold button, and that essentially just interrupts any machining that you're doing at that time. So if you're running something really quickly and you need to quickly change something or do something but you don't want to stop the machining, it's really nice to have a little button there. I can just quickly press it and it pauses the machine program at that time. I can quickly fix what I need to and then press play back on the computer, and then it continues as normal. So if you do have the ability to put in an interrupt into your system, it's something that I would certainly suggest doing. Now on the front of the machine, you can see that I've got a USB input, so I can use I use Universal G-code sender for a lot of my computer-based CNC control work. I have an SD card there. Now, I'm going to talk about the SD card because that's really important as part of the offline mode of this machine. And I've got an e-stop too. So the e-stop is, I just click it once, it shuts off the machine completely. And I just use that as an on and off button mainly for my machine at all times. Now at the back you saw that I have the 2 outlets for the electricity. And I also have my on and off buttons as well. So they're also a dead switch as well. I can switch it on and off from the back. So there's definitely no power going to the machine. So comes to the most important part of this build is what actually controls it. Now I'm using a Garble or GRBL based system in this build, and that's by a company or a system called FluidNC. Now FluidNC is a Garble based system, but they've been able to improve it and add it to an ESP32. Now ESP32 is essentially like an Arduino, but it is a much quicker, much faster version of the Arduino. It also has on the actual chip itself, it has a Wi-Fi module and a Bluetooth module. And that brings me to why I really love this machine and why I decided to go with FluidNC. So essentially what I can do is I don't have to tether it to a computer. I can attach my phone straight to the Mpcnc. So I turn it on and suddenly the Wi-Fi signal comes up, I connect to it, and then I can go straight ahead and control the Mpcnc straight from my phone. And I can also then, using the SD card at the front, I can run my files straight from my phone, which is a really incredibly helpful feature, especially if I'm taking this around and I don't want to lug a computer. Unfortunately, the FluidNC is still a developing software. I've had a lot of bugs with the FluidNC. Now, one of the main bugs is that it just stops halfway through a job, and I don't know why, but I think that it's got to do with the Wi-Fi chip overheating and creating issues for the actual ESP32. So I think it's one of those things that's evolving over time. And it's something that I might add a heatsink onto it to try and keep that chip nice and cool. Now let's go and have a look at my my drivers that I'm using. I'm using the same drivers as I did on my rotary CNC. Now these are TMC 2160 OC versions. Now these are standalone motor drivers, and essentially they're just hooked straight into the ESP32, which have control over it, and then one of those motor drivers controls two of these Nema 17s. So I've been able to double the load out of the motor drivers to control two of the Nema 17s. And unfortunately, the lowest I could create is about 2.5 amps output of the Z-axis, even though I'm only using a 2 amp motor, and I haven't had any problems with that, so it's been really good. Now the reason why I decided to use them is that they're super quiet, silent motor drivers, and they're very effective in what they do. So at no times do I ever have any skipping or any jamming or any issues with these. They work really, really nicely. So I'm impressed with using these motor drivers, but there is a sacrifice that I did have to make. And one of the things that I wanted to do with this machine is when it homes at the beginning, so it goes up and finds its 0 point, so I wanted it to square itself as well. That means that both sides of the machine would bump up against the end stop trigger. So I found a little workaround it is that I've wired the end stops in series. So that means when this side comes to the end of its travel, it will go hard up against its limit and waits for this second side to do it. And it's usually only a split second in between it, so you'd get a slight little grind, but that's okay. I'm not really too worried about the motor grinding if it hasn't been exactly square. But you know, after you've used it once, it's already square, so next time you go to use it, it seems to be quite square when it homes itself. So only get that slight grind of the motor because one side of the axis isn't perfect with the other. That only happens very rarely. So I'm not too worried about it because these belts seem to skip, and no issues really with the skipping of the motor. So I have included all the 3D files on my Thangs profile. Just remember, I've got two lots of Mpcnc files up there. So I've got the ones for the Primo, and then I've also got my older version for the Burley version as well. So please just make sure you do download the right files for the right machine. And I've also uploaded the files to cut the base of this. Now the base of this can be done quite simply. You can cut out using a bandsaw, and just using a router table, you can put a 60-degree chamfer end mill, and then you can go along and cut all your angles as you need to. But I'll put it up there for experimentation. If you want to go ahead and build it, that's certainly there. I really like the design. It includes some 3D printing and also a really solid and rigid base for your machine to go on top, and you don't have to lug around another computer because all the electronics are underneath this machine. So let's jump on to the creative side of what I've been able to do with this machine and how much I can push this machine to its limits. So let's check it out. Before I get started with all the creative side, I want to talk about how fast I've been able to get this machine. And to be honest with you, I started off with very conservative speeds of about 1,000 millimeters per minute. And that worked out really well. I didn't have any issues at all. So in the spirit of experimentation, I thought, well, why not just take it to the maximum and see what happens? So I put it on 100,000 millimeters per minute, and it still worked, and it worked really, really well. Unfortunately, I did have a slight issue with when it did come to a pause or a stop and it wanted to change direction, because it was going so fast and my acceleration was so low, so it didn't slow down before that point. As it took off again, it would actually skip the pulleys on the belt. Very similar to like driving a car, and if you're doing a drag race, that at the beginning of the drag race, if you floored it, your tires would spin. So that same thing happened here. So when the machine came to a position and took off again, it just skipped on the belt. Now that's not a good thing, obviously, because you lose your position and compromises the job. But what I was able to do is tweak the acceleration settings so that when it took off, gently, and so it ramped up its speed and then got to its maximum speed and ramped down. Unfortunately, that means that I could no longer reach the maximum capability of 100,000 millimeters per minute, which is absolutely fine. So I've been able to achieve about 60,000 millimeters per minute on this machine, which is really exciting, and that's something that I never thought was possible. And so it does it quite safely, and so it ramps up and ramps down. So you can see here it starts off slowly, reaches its maximum and dies down. And you can see within that time that it never would have ever reached its maximum speed, just because the ramping takes so long. So I'm going to start off with some of the experiments that I've done with a pen. So I've just added a pen onto it, and this is usually something that you would do when you first start off with using this type of machine. You would draw the crown. This is a test file that Ryan's made available. And so I went ahead and created this. I did this on a large scale and also a small scale. It was really great to test how fast I could run the machine. So I started off with drawing the crown, and then I moved on to bigger and better things. So some of the experiments that I decided to do was experiments that would be based upon using like a continuous line drawing. So I started off with some really strange and wacky designs within these spiraling lines that were kind of this organic formation, and that was really successful, and I think that it came out really nicely, and I would certainly want to develop these ideas even further within this idea. So using this kind of motion which just keeps on going and going to create some kind of mesmerizing organic shape. That was a lot of fun. I've also done a lot of ideas with patterns and overlaying patterns and different colors together using patterns. So this one here is just once again using a continuous line drawing, which would just pretty much print over and over again on the page. I had some problems when I was running this because I was running it directly from the FluidNC via my phone, but unfortunately I'd only get so far before I think that the Wi-Fi system decided to overheat and then stop the program. So it was really fun. I could then stop it, flip it over, do it again, and do it with a different color. So it was a little bit of fun having a bit of a play and seeing what else I could do and seeing how it would turn out. It's kind of the machine making up its own decisions. I've also done this still life drawing too. So I really like this drawing. This took me hours to draw on Illustrator, but once it's drawn and you've got the digital file, you can just go through, and I think that it completes this within about 2 or 3 minutes. And so you can see this video there that it's going through, and the tiny little detail that this has been able to achieve, and so fast. It just blows me away about what I've been able to achieve using this Mpcnc, but it's just absolutely beautiful, the works that you can create using it. So this is the full pattern version. You can see there was a slight low spot in the center, which it didn't come out, but I quite like the mistakes that happen when you're using the machine to create art. Is obviously just a spot where the pen didn't reach at a certain point, but I think it gives it a really nice focal point for this pattern, and it's not perfect, and I like that about the this type of artwork. So I also was able to use paint pens, and paint pens essentially are just like pens but have a flexible end to them, so they kind of mimic paintbrushes in a way, so really helpful, especially if I want to be able to create different depths and thicknesses of lines using the machine. So essentially what I did was I went aside and created another contour drawing. So contour drawing, this just the pen doesn't come off the page at all, but this one I did use a V-carve setting on Fusion 360 to say that when my line was thicker, that would push the pen further in, and when it was thinner, that'll pull it further up, and to create kind of some different variations within line. So this is a picture of a lady that I traced and created myself through Adobe Illustrator, and also made a different version of her as well. So this one is kind of like a pop art inspired one. This one just uses different colors in different parts, as well as using that continuous contour line as well. A couple of other things that I've been able to do is this one here. So this one here is using a spiral line. I'll include the online app that I used for doing this. So you could just upload an image and it'll turn it into a spiral image for you, and if you can kind of see that there, it has a thumbs up, so it might give you a little hint on what to do on the video below. If you like this video, feel free to give me a thumbs up and subscribe if you want to. I've also put there this one too. So I redid the still life picture I did before, but using a paint pen as well. And I really like this one because sometimes the paper was a bit warped in some areas, so when it was further up, that it hit the paintbrush a lot heavier and those lines came out thicker, vice versa, thinner lines as well. So that really natural paintbrush experience came out while using this technique as well. And the very last one, I decided to extend on my ability, and this was meant to be a self-portrait of the Mpcnc, so a little bit of a fun project to do as it paints its own self-portrait. It didn't really work out as I expected, but that's okay because the journey itself was really exciting, really fun. So when I created this, I put the paintbrush on the end, I put paint on the side of the artwork on another piece of paper that I could just unstick and swap it over with a new color. But the idea with this one was that every time that I programmed it in Fusion 360, so anytime that the Z-axis would lift, I injected another piece of code for it to go and wipe and take some more paint. So, and I just did that through Notepad++ and just used the replace function to put that in there. So that was a really nice, handy little experiment that I had with the machine. And so besides using paintbrushes and pens for the experimentation on this machine so far, I also added a laser module. So I have a couple of different laser modules here. This is the one that I've had for quite some time. This is the Nema, they call it the 30 watt, but it's only about I think a 5.5 watt or a 5 watt laser module in here, and it's a diode laser. So they work really well for engraving, and they can also cut thin materials like 3mm ply. It cuts really well. But I decided I wanted to have a bit of a go and see which one, because this is a nice standardized test or machine that I could use my laser modules on. So I have the Nema, I also have the Afuro. Now this one is pretty much has the same laser diode output, so I think that this one's 5.5 watt as well, and I think this is the similar. So it was nice to compare these on this machine and see which one that I would like to keep in long term. The only issue is that to the main gantry here, I've put a 12 volt channel, so I could use that for different attachments, but this is a 12 volt module, this one's a 24 volt module. So I had to add a new module, a new power supply to get this one going, but that's absolutely fine. If I knew that beforehand, I probably would change it because this one does have the 24 volt capability too. So I just added my own little cables in there and I've hooked it up to the machine. and attached it to Lightburn. Now these worked really well, and I did a couple of tests to see which one of these I'd like to use in the long term on this machine. The results really speak for themselves. So I first started off with the knee G. I did an engraving. The engraving on both sides of these modules are about the same, but then when it comes to cutting, unfortunately the knee G was a little bit more messier. So the lines were a bit more charred, and weren't really as neat, but the furrow ones came out super neat and very little cleanup at the end. So I believe I would use the furrow on this machine in the future. It's really nice because I can put it on this machine and it has quite a large area that I can use the laser on. I can do large engravings, small engravings, and I can also use it to cut 3mm pieces of plywood as well. So I'm super excited to see what I can do with this machine in the future. Just as a bit of a wrap up, guys, I really appreciate you watching my video and checking out my build of the Mpcnc Primo. There's a lot of things that I've added into this machine, a lot of things I'm really proud of, and it's really exciting to see how far that my knowledge has come over the years of building an Mpcnc and other CNCs. Now, I would really suggest, if you're interested in getting a CNC for your very first one, you have a 3D printer, you like to tinker with things, and you got lots of time to do it, jump into one of these projects because it's one of the best things that you could do as the beginning of your CNC life. And certainly look into different options for the electronics, because I know that the electronics have a really big impact on how the machine works overall. So autonomously, this machine works beautifully, and I can just home it at the beginning and I can press play and off it goes. And essentially that is what's really captured me about this build, and what really excites me about taking it out there and showing people about what you can do with CNC and how flexible and how easy it can be. So thanks very much everyone for watching my video today, and please, if you haven't done already, subscribe, give me a thumbs up, go check out the downloads page of my Thangs profile, and I've also put a couple of websites down below as well, which is really helpful for creating some of these creative files and creations that you can do for yourself. So thanks very much guys, and I'll see you next time.